Hi, my name is Patrick Tran from the University of New South Wales, Australia. In this presentation, I'm going to give you an overview of learning analytics with reference to our paper, and more importantly, how is it being used to improve the course delivery at our institution. In particular, we will cover the what and the why of Learning Analytics LA, and then we're going to walk through a number of LA applications, including analytics tools available in Moodle LMS, Power BI dashboard, and predictive modeling. We then take a closer look at a learning analytics maturity framework and some critical issues that you need to pay attention to when analyzing educational data. So first of all, what is learning analytics? Let's have a look at this picture here, which is an interesting tweet, one of my favorite. On the left-hand side, we have this beautiful organic piece of tree. It represents the learning process, which is a very rich and complex phenomenon. We then try to measure this process by dissecting it into smaller pieces, do some counting, and come up with a bar graph with some statistics. So this process of converting a rich and complex phenomenon, in this case learning, into a simplified and quantifiable representation is exactly what learning analytics is all about. It is about simplifying and measuring the learning process. The other direction is also important. Does the result aligns with what already know of the world? Meaning that as LA practitioners, we need to be able to validate and relate our model to the reality. Here we have the formal definition of learning analytics, but I would like to offer you another way to think of it. Imagine that you are walking on a hard, clean surface. You are not leaving any traces behind. The question here is, how are you going to make these traces visible? And that is what learning analytics can do very well. We basically define the metrics to measure learning, and then we can capture the learning process by using these metrics. We can now provide feedback to students and educators so they can refine their performance accordingly. And that is the whole purpose of learning analytics. So why learning analytics? Well, first of all, we now have access to a lot of data generated by online learning platforms, and the technologies are becoming more and more affordable nowadays. So it makes sense for institutions around the world looking for ways to capitalize on this rich learning data. Secondly, learning analytics can help improve the feedback loop. It is simple if you have a small class and you want to know whether students are following you or not by just looking at their facial expressions. However, it is going to be very challenging if you have a very large class or online courses, and that is what learning analytics can do very well. There are also other reasons why you should do learning analytics, including empowering, motivating learners, understanding the factors that may affect learning, and transforming education from reactive to proactive. In this presentation, we are not going through all the techniques and applications of learning analytics. Please refer to our paper for the details. Instead, I would like to show you learning analytics in action. How is it being implemented at our institution? We use Azure Synapse Analytics as the backbone of our learning analytics solution. This is a cloud computing platform that integrates different data services within the Microsoft Azure ecosystem, ranging from data ingestion, data storage, data processing, and data serving. Essentially, we are collecting data from two different systems: the student information systems for demographics, transcript, and program details. And for learning management systems like Moodle, we are collecting learning behaviors and engagement data. Once collected, the data will be stored in a data lake storage Gen 2, optimized for structured and unstructured data. And then we use Apache Spark to process big data. After that, the data will be stored in our SQL data warehouse, which is then connected to other linked services such as Power Apps, Power BI dashboards, and Azure Machine Learning. Here are the four use cases of learning analytics that we are going to look at today. The first two are the tools available in our LMS system. We then look at the Power BI dashboard and Azure Machine Learning to predict student at risk. Here we have some analytics reports available in Moodle LMS. They are all centered around the standard log. This logging system captures every move made by the students within the system. If you're not familiar with these reports, please refer to this link for more details. Within our instance of Moodle, we have some special reports developed by OpenLMS, which are called correlation reports. These reports display performance and engagement side by side. For performance, we have average grade or grade distribution, and for engagement, the report shows the number of views and posts. Looking at the performance and engagement side by side like this is very interesting, and hopefully we might be able to identify or discover some patterns within the data. So it is important that you have some good reports generating insights into what's going on with your courses. The more important question is, what are you going to do about it? And that is the actions or interventions that you need to do based on what the data is telling you. Here we have the Personalized Learning Designer or PLD tool available in our Moodle instance. It is essentially a rule-based intervention system, so we can define a rule with some trigger events, conditions, and actions. In this example here, the trigger is when a quiz is graded, the condition is if the student failed the quiz, and the resulting action is navigating to another activity, which is a new page for supplementary contents. At the beginning of the pandemic, we had to switch our teaching to online delivery almost immediately. One big challenge to us at that time was how to increase our visibility into the student experience in the online space. To do this, we used Power BI dashboard to monitor student online engagement with data from our LMS. In this dashboard, we are using two engagement metrics, which are very simple and straightforward: the percentage of active students and the number of hits per active students. We visualize individual courses on the scatter plot to compare them against the two metrics. We also aggregated the data into a combo chart for school-level comparison. At the top here, we have a view of historical data showing engagement metrics across different weeks throughout the entire semester, explaining how engagement evolves over time. We could quickly identify the bottom 5 courses in terms of online engagement and a list of inactive students in the program. Predicting student at risk is the most recent development at our university. The dataset we are using is the historical transcript data. Each row in our dataset is an enrollment entry, so we have a particular student ID enrolled in a course code in a particular term. The rest is the historical academic performance data. The target variable that we want to predict is the risk category. A student belongs to the OK category if he achieved pass, credit, distinction, or high distinction. Otherwise, that will be the risky category. That means if a student failed or dropped out from the course, the label would be risky. The features we are using for our model are the number of courses the student attempted, the number of times the student failed this course previously, the cumulative grade point average or GPA for this term, GPA change from the previous term, dropout rate, fail rate, and so on. We also have many more features that we haven't included in our models, so we may try to use them in the future. One thing I would like to mention is that our dataset is very much imbalanced. So we have more than 90% of our students were in the OK category. So if we had trained our models based on this original dataset, our models would have been biased towards the majority class here. As a result, we had to implement data mining techniques such as oversampling to alleviate this imbalance problem. We tried a number of machine learning algorithms, and logistic regression appeared to be the best performing model with the highest classification accuracy and highest recall. This is confirmed by the ROC analysis. Now, looking at the confusion matrix, out of 163 students who were actually risky, we could detect correctly 147 of them, equivalent to a recall of 90.2%, which is a very high accuracy. We then used logistic regression model to predict student at risk in our new semester data. So even before the semester starts, by just looking at the students' enrollment patterns, which course they enrolled, and the historical performance data, we could identify their risk level. So for example, the first students here, the algorithm calculated the probability of the student being risky was 27%, which is less than 50%. So the prediction label was okay. We could do the same thing for other students. To further assign a risk level, we can compare the prediction probability with some threshold values. For example, level 0 for probability below 10%, level 1 for probability between 10 and 20%, and so on. Here we visualize the entire data mining process that was used in our project. To understand how advanced your institutions are with respect to learning analytics, we can use this maturity framework that is based on two metrics: the development level from beginning to advanced, and the organizational impact from limited to integrated. The first level is where you use existing reports available in LMS systems. The second level is where you developed more advanced reports yourself. Level 3 is when your LA systems support multiple user roles and have some decent descriptive analytics. Level 4 is when you target more advanced analytics, such as predictive modeling, and could achieve some organizational impact. Level 5 is open analytics, referring to any innovation that could transform the entire sector by sharing data among institutions. In our case, the University of New South Wales is definitely level 1 because we've been using the built-in reports for some time. We are also level 2 because we have developed advanced Power BI dashboards. We are level 3 because our LA system could support multiple user roles, not just students and educators, but also system administrators and other stakeholders. We are somewhere between level 3 and level 4 because even though we haven't done much of predictive modeling, but we could achieve some significant impact across the board. Here are some critical issues that you need to pay attention to when analyzing educational data. The first and foremost is ethics and data privacy. You need to obtain consent from data subjects, ensure data privacy and security, and your learning analytics applications needs to be in service of learning, meaning that learning analytics cannot hinder or cause any negative impact on the student progression in any way. We also have a checklist of things that you need to look out for when it comes to the ethical use of educational data. Another challenge of learning analytics is how to interpret analytics results. According to research, you need to have 3 different kinds of organizational intelligence. You need to understand the process that you are measuring. You need to have some technical understanding and working knowledge of data analysis techniques, statistics, and LMS systems. You may also need to have some familiarity of the political structure and decision-making process of the organization. This will help you successfully interpret analytics results. You also need to be able to validate the models that you come up with by checking whether the models are still applicable to the current context, which can be the same or different from the training context. And finally, you need to be creative with your feedback to the analytics users to make sure that your feedback is as personalized and actionable as much as you can. And that's the end of my presentation. I'll be around if you have any questions. Thank you.